So both method is used to solve the linear equation. Okay, this one we call linear system of linear equation. So different of Jacobi and Gauss-Seidel is Jacobi is both you have to use both have to make sure it's diagonal dominant. Sorry, I close and open again. Okay, so both must be diagonal dominant. Only we can use Jacobi and also the we can use Jacobi and also the Gauss-Seidel method in order to solve it. Okay, what is the diagonal dominant? Your diagonal here, okay, must always greater than another two number add together. Okay, we don't care negative or positive. Okay, we change everything to positive. Okay, we don't care negative or positive. So basically, they are the same, but what is different is if Jacobi, when you calculate for r plus 1, okay, we always use r and r only. But for Gauss-Seidel, it's a bit different. Okay, for Gauss-Seidel, when you have r plus 1, okay, when you calculate for r plus 1 for x1, we use r. But when you calculate for x2 r plus 1, the x1 r plus 1 is being used already. Okay, not wait until next round. Okay, direct we use it. So this one normally will be faster. Okay, normally we'll get the answer faster. Okay, faster and then we get the answer. Okay, why we need this one? Diagonal dominant. Okay, if you check reference book or textbook or anything, okay, why they need diagonal dominant? Because if it is not diagonal dominant, your answer will keep changing, keep changing until until infinity. They still keep changing. Okay, they won't converge. We said converge. Okay, they won't converge or focus lah. That in other words is focus lah. But we don't use focus. Normally we say converge. They don't converge to one point. They won't stop at one point. Okay, so that's why it must be diagonal dominant. Okay, so we have two methods here. Um, okay, maybe we will do a tutorial first. Okay, I do the question one first. I think you have done the question one, two, is it? Or not yet? You may do first if you want. Question one, two, by using the Gauss-Seidel and also Jacobi. Maybe you try first. I give you a few minutes. Okay, so we have a look. Okay, so just like what I said, okay, just like what I said last week, this one, if you direct tag, you cannot, if you direct tag, it will be something like this. 1, 5, -3, 7, 1, 2, -1, 1, 7. Okay, if you direct tag like this one is not diagonal dominant. If you check second row or the first row, you will find it 5, 1, 1, 1, 7, 1. 7 is much greater than 1 and -1. Okay, 5 is also greater than 1 and 1 here. So what we do here, we swap, we change our row. Okay, we make it into 5, 1, 1, 1, 7, -1, and then -3, 2, 7. Then now only is diagonal dominant. Okay, so after you have a diagonal dominant, so now, okay, we need to check we need to get the formula first. Okay, so in order to get the formula, so we have the formula. Let's say now I'm doing the Jacobi first. 2020跟2019啊，你填了应该会有一个什么一个 copy 还是怎样吧？你把它也 download 下来，然后给他。Okay, so now we continue. So I want to get the x1 r, it will equal to, okay. Now this one is in order to get your x1, okay, don't forget. So it will be everything you move to the back. So 9 minus I minus x2 r. This one is r plus 1. My mistake. R plus 1 minus of x3 r. But your x1 divided by 5. So everything divided by 5. Okay, and then x2 r plus 1 will be equivalent to, now we use this one as x2, don't forget. Okay, so 1 over 7, 3 minus x1 r plus x3r. Okay, x3 r plus 1 will be equivalent to 1 over 7 also. My mistake. Yeah, correct. Sorry. Let me check. Okay, 1 over 7 times 17 plus 3x1r minus 2x2. Okay, minus 2x2. So as long as your change is less than 0.01, then you may stop. Okay, so now we try to do. One minute, let me get calculator. Okay, so okay, normally they will set you start with what? If they are not saying, then you just put 000. Okay, if they are saying, then you have to follow them. Okay, so when your r is 0, okay, when your r depend lah, you want to use 0 or 1 first, up to you. Okay, let's say you put 0, then it is start with 000. Okay, depend. Again, you may use 0, you may use 1. Let me see. If you, according to here, they use 0 first. Okay, so I continue. So 000, so it will be x1 will be 9 minus 0 divided by 5, so 9 over 5. So this one is when your r is 1. So this one will be 9 over 5. Okay, this one will be 3 over 7. This one will be 17 over 7, because the rest all is 0. Then now you may continue with 2. Okay, 2 it will be, okay, so you have to put in your x2 3 over 7, x3 17 over 7 in order to get the x1 2. Okay, so 1 over 5 times 9 minus 3 over 7 minus 17 over 7. So 43 over 35. If I did any mistake, please let me know. Okay. I don't want to use this one. I use decimal. So that easy to compare. 1.229. Okay, and then next one will be 1 over 7 times 3 minus the first one 9 over 5 minus the third one 17 over 7 plus, sorry. So I get 0.518. 0.518. Okay, next one. 1 over 7 times 17 plus 3 times 9 over 5, so 27 over 5, minus 2 times x2, which is 6 over 7. So I get 3.078. Okay, thirdly, so 0.2. You can change this one into the decimal, or you want to leave it like this also can lah. Okay, I mean this one I change to 0.2, and then 1 over 7 also change it to decimal, something like that. Okay, up to you. Okay, 9 minus 0.518 minus of 3.07. 1.0808. 081. Okay, and then 1 over 7 times 3 minus 1.229 plus 3.078. 0.693. And then 1 over 7, 17 plus 3 times 1.229 minus 2 times 0.518. 2.807. Okay, number 4. 9 minus 0.518 minus 3.078. Sorry. 9 minus 0.693 minus 2.807. 1.1. So you see the distance, their distance is getting nearer and nearer. This one and this one and this one, the 2 and 3 is bigger than the 3 and 4. So 4 and 5 will be smaller and smaller. So 1 over 7 times 3 minus 1.081 plus 2.807. Okay, 0.675. Okay, next one again, 1 over 7, 17 plus 3 times 1.081 minus 2 times 0.693. 2.694. Okay, so 1 over 5 times 9 minus 0.675 minus 2.694. If you found any mistake, please let me know. Just now is 1.1. 9 minus 0.693 minus 2.807. Yeah, okay. 1.1262. Oh, sorry, 126. 0.656. 2.707. 1.127. 0.654. 2.724. Alamak. So since this one's still not enough, I said when I have less than 0.01, then we stop lah. But this one's still not yet. Okay, still greater than 0.01, so it's not fulfilled the condition yet. So we continue lah. Normally the question will tell you you have to do how many iteration. Let's say if 5 iteration, then you have to do until here. Okay, they said when your error is less than 0.01, then you can stop. Then you have to continue. Okay. So it's depend on the criteria. One point 124. So you can see, okay, 1.126, 1.127, 1.124 is somewhere around okay, between 1.127 and 1.124. It's like going up, down, okay? 0.658. This one also the same thing. 656, 654, and then 658. Going up, down, something like that. So it's around this area lah, the actual value. This one I get 2.728. Okay, so I will stop here. Okay, because 0.01, so it's fulfilled already. Okay, so that means my x1 will be 1.124. My x2, according to Jacobi method lah, 0.658. X3 will be 2.728. So it depend on which method you are using. Okay, this one is Jacobi method, so you have to do a bit longer. If you are using the Gauss saddle, maybe it will be faster. Okay, Gauss saddle, basically the formula will be the same. Okay, but this one change to R plus 1. This one change to R plus 1 plus 1. Okay, again, your turn to try the Gauss saddle. Okay, so we have look if Jacobi, then how? I do here so that later we can compare. Okay, so when this is 0, again we start with 0, 0, 0. Okay, your x1 still the same, your 1 will be the same, which is 9 over 5, which is 1.8. Okay, second, 3 minus 1.8, okay, divide by 7, 0.171. Third, 17 plus 3 times 1.8 minus 2 times 0.171 divided by 7, 3.151. 2, 9 minus 0.171 minus 3.151 and then divide by 5, 1.136. So you can see, okay, much faster. Okay, here in order to get 1.1, you have to do until at least third I means the third iteration only you can get 1.1 something or 1.0 something. But here, second iteration you already get 1.1. Okay, and then 3 minus 1.136 plus 3.151 divided by 7. So 0.716. 17 minus 3 times 1.136 minus 2 times 0.716 divided by 7. 1.737. So see, first round they already like going to the up down already for the third and second. Okay, from the lower point to the upper point. Okay, this one also the same. The x1 still not yet lah. Okay, we'll continue. 3. 9 minus 0.716 minus 1.737 divided by 5. 1.309. Okay, 3 minus 1.30. 3 minus 1.309 plus 1.737 divided by 7. So 0.4 cannot be 489, 0.49. 17 plus 3 times 1.309 minus 2 times 0.49 divided by 7. 2.85. Fourthly, continue first. Okay, so fourthly, 9 minus 0.49 minus 2.85 divided by 5. So 1.132. Okay, 3 minus 1.132 plus 2.85 divided by 7, 0.674. 17 plus 3 times 1.132 minus 2 times 0.674. 2.721. So it's very near already. Okay, we continue again. So 5, 9 minus 0.674. Okay, 9 minus 0.674 minus 2.721 divided by 5, 1.121. 3 minus 1.121 plus 2.721. So 0.657. 17 plus 3 times 1.121 minus 2 times 0.657. 2.721. Okay, we can see our x3 does not change already. 1.124. 0.657. 2.723. Okay, so this is what we get lah for Gauss shadow. Have a look. You have a look first. Huh? I get something. Okay, we continue first. How to get the general formula? It means how to get. Okay, this one is depend on this equation. This one. Okay, so now your
Sir,
equation is what?
haven't shared.
X1 plus X2 plus X3.
Sir, haven't shared.
Sorry?
Haven't shared your screen.
Oh, okay. Sorry. Okay, so from the because we arranged this one as our first equation, so I have 5x1 plus x2 plus x3 equal to 9. So from here, this is a first equation. So from here, I want to get the x1. So we move this one to the back. So become 9 minus x2 minus x3. And then I only want the x1, so divide by 5. So 1 over 5. So that's why I have this one. For the second, I use this one. I use the first equation. So I take 3 minus of alamak. Yeah, 3 minus of x1 plus x3. And then everything divided by 7 because I have this one. X1 plus 7 x2 minus x3 equal to 3. So again, I move this one and this one to the back. So become 3 minus x1 plus x3. And then everything divided by 7. So 1 over 7. Same thing for third one. We move x1 and x2 to the back. And then everything divided by 7. Is it okay? Am I answering your questions? Okay. Yeah. Well, okay. Why we swap? If you don't swap, I cannot get the diagonal dominant. Okay. If you doesn't swap, okay. If you doesn't swap, okay. If you doesn't swap, you get the equation. You get the matrix like this. Okay. You get the you take 1, 5, negative 3, 7, 1, 2, negative 1, 1, 7. If you doesn't swap, you have something like this. Then it is not diagonal dominant. Why it is not diagonal dominant? Because this one is not greater than these two add together. This one is not greater than these two add together. Okay, this one, yes, is greater than these two add together. Okay, but the first one and the second one is not diagonal dominant. So that's why I swap the first one and the second one so that this one is greater than 1 plus 1. This one is greater than 1 plus 1. This one is greater than is greater than 3 plus 2. So now it is diagonal dominant. Then only your answer will be focused, will be converged to some point. If not, your answer won't converge one. Okay? Clear? Okay, so I continue with A. I don't want to do. Okay, A. I don't want to do. What I means one. I don't want to do. Okay, you. This is the answer that they have lah. Okay, you may compare lah. Might a bit different. 1.124, 0.658. Okay, 2.723 might a bit different because their condition to stop is different. Okay, maybe their condition is 0.001. Okay, so you have to do more step in order to get a difference of 0.001. Okay, but this one I just want to tell you how to do, so I don't let the error become so small. Okay, so this one also the same lah. Okay, so if let's say you make it into the 0.001, only you can stop. Okay, then you need more step. And the difference between the Gauss settle and the Jacobi, okay, and this Jacobi will be much different. You will see, okay, Gauss settle maybe do the 7 step, it's already can stop. But the Jacobi, you need to do until the step 9, step 10. You need to do extra much more step. Okay, so most of the time, not every time lah, but most of the time, okay, Gauss saddle will be easier than the, I mean not easier lah, but faster than the Jacobi. Okay, so we continue. Okay, this one is another method in order to solve the system of linear equation, which we call decomposite or factorization of a square matrix. Okay, so we have two methods here. The first one is called LU decomposite. So what is LU decomposite? Okay, so LU decomposite is we try to make our matrix. Okay, for example, our matrix just now we have this one. We have this one. This one is our A. Okay, what we do here, we try to make our A into a lower triangular matrix times the upper triangular matrix. Okay, with condition upper triangular matrix, the diagonal must be 1, 1, 1. Okay, so what we do is we try to compare. Okay, we know that this one and this one, I get 3. So that means L11 is equal to 3. So that means I know my L11 is 3. Okay, and then we use this one times this one in order to get -1. And we continue until we get the odd number. Okay, L11 is what, U12 is what, U13 is what, L22 is what, U23, L32, L33. And hence, okay, I get the L and I get the U. Okay, after I get the L and then I get the U, what is the purpose I get the L and U? Okay, so now we have look. This one also the same lah. I give you A and then you try to get the L, you try to get the U. Okay, so you get everything. We try to get the L22, U23, L32, L33. So after you get LU decomposite. What's this? L12, L21, L31. Okay, normally this one will be equal to this one. Okay, and then this one will be equal to 1 over 3 times this one. Okay, later we will see lah. Later you will see. Okay, this one after done. Okay, LU decomposite of a square matrix A. Okay, so we try to find again lah. Our target is we try to solve the system of linear equation. Okay, so this one is when you want to find this one, you want to find the modulus of A, it will equal to the modulus of U times the modulus of L. Okay, and then your A inverse will be 1 over A, 1 over of modulus A times the adjective of A. Okay, so now I want to find the solution of Ax equal to B. This is what we want to find. This is one of the other application. Okay, but our ultimate target is I want to solve this one. Okay, so how we're going to solve? Okay, this is the basic idea. So let's say my A is equal to LU. Okay, and then because what we have is Ax equal to B. So we substitute A as LU. Okay, so A is LUX. So I will have LUX equal to B. And then we let this part equal to Y. Okay, so Y equal to UX. So that means I will have LY equal to B. LY equal to B. Okay, LY equal to B. Hence, we can solve it for X. Okay, we have a look how we're going to do it now. Okay, so first I have this equation. this system of equation, and then my A will be 3, -1, 2, and then 1, 2, 3, and then 2, -2, and then -1. So this is my A. So what I have to do now is I have to make my A into the LU. Okay, so blah blah blah. This is a process. Oh, they direct jump to the answer. Okay, so they get the L, they get the U. Okay, so again, now I have ax equal to b, x equal to b, so this is my a times my x, okay, x is xyz lah, equal to 12, 11, 2. Okay, so what is my y? Y will be u times my x, so this is the first equation. Second equation is ly equal to b, so I have these two equations. Okay, so from the second equation, ly equal to b, so I take this one. Okay, I take this one times my y. I don't know what is my y. I just assume it's y1, y2, y3 equal to my b. What is my b? My b is 12, 11, and 2. So 12, 11, and 2. So I try to get my y1, y2, y3. Okay, I try to get my y1, y2, y3. So after I get my, you just times inside lah. This one times this one is equal to 12. So that means my y1 will be equal to 4. And then you have 4 here, so you can get your y2. So after you get your y2, you have y1 and y2, then you can get your y3. Okay, so that's why we need a lower triangular matrix so that I can easily get the answer from start from y1. Later you will see again lah. Okay, so you can get your y1, you can get your y2, you can get your y3. So after you get your y1, y2, y3, so this one will be your y equal to your this one times your x. So this one will be your y times your x times your equal to your what I'm talking. Okay, your L times your x, and then you will get your y. So again lah, 1z equal to 2, so z equal to 2. Okay, and then 1y plus 1z equal to 3, but I know my z is 2, so y is equal to 1, and so on. So I get the z, I get the y, I get the x, and hence I get the answer. Okay, so before I proceed again, you try to do the number 2. Yeah, try to get the number 2. When we say crop method, that means it's LU decomposition, LU composition. Okay, try to do it. Number 2.